Let's take a look at another example from Chapter 10. The average length of short hospital stays for men is slightly longer than that for women, 5.2 days versus 4.5 days. A random sample of recent hospital stays for 32 men had a sample mean of 5.5 days with a population standard deviation of 1.2 days. A random sample of recent hospital for 30 women had a sample mean of 4.2 days with a population standard deviation of 1.5 days. At alpha equals 0.05, is there sufficient evidence to conclude that the average hospital stay for men is longer than the average hospital stay for women? Now, this question is a little bit trickier because this is already having some type of larger claim being made. So we assume that this is probably made from prior research, that this first statement that says the average length of short hospital stays is slightly longer for women or for men than it is for women. So we assume that this has to do with something about the population. So we are trying to do it based off of some type of test, some type of statistics here, some sampling. We're trying to figure out, is this claim true? Do we really believe that indeed men do stay longer for these quote-unquote short hospital stays than women? So what we have now is, again, we have hypothesis testing, we have our null hypothesis and our alternative hypothesis. Now, because we're looking at these two different groups of people, we have the men versus the women. There's no overlap between them. We really see these as independent samples, and we're trying to see, is there a difference between these two samples? So we can use some subscripts to help us understand this. I'm going to use mu sub m is going to be the mean for men, and I'm going to use mu sub w is going to be the mean for women. So my null hypothesis says that these two are equal to each other. Mu sub m is equal to mu sub w. Our alternative, we're trying to figure out, is the average stay for men here longer than that for women? So we're wondering, is mu sub m going to be larger than mu sub w? So now when we figure out which test we want to use, we indicate here that we have two samples. We are looking at means. In both these cases, we have known population standard deviation. So we know the population standard deviation. And the last thing we could also mention if we want to is that this is a one-tailed test. So these three, we see that we want to use a two-sample z-test. So if we go over to our calculator, we click stat, we go over to tests, we go down to two-sample z-test, we enter in our statistics, so we'll call these subscripts here, this would correspond to, say, a mu sub 1, and this, for the sake of the calculator, would be mu sub 2. So my first population standard deviation is going to be 1.2. Our second population standard deviation is 1.5. Our first average, remember these are samples, so don't be confused. This over here, remember these had to do with populations. We had our sample here of the 32 men had a sample mean of 5.5 days. So we want to put in 5.5. The total number we said was 32. Sample mean for women, we said, was 4.2. And the number of women that we collected data from was 30. We go down and now we see our alternative hypothesis. If we said that our mu sub 1 corresponded to the men, well, the men here was going to be larger than the women. So we want to go over here and choose the larger. And then we calculate. So we have our test statistic. Test statistic we see is z is equal to 3.753. Now remember, this is super far away, right? If we look at z-score charts and we're over here at 3.753, we know to be as extreme or more extreme is going to be over here. This is very, very, very tiny amount of area. So if we look at this p-value, our p-value is not 8.7. What we have is this e to the e minus 5. This corresponds to scientific notation. This is 8.7, say 5, times 10 to the negative fifth. Or in other words, if we move this decimal place 5 spots, 1, 2, 3, 4, 5 here, we have 0.1234875. This is a super tiny value. Now, so if you round this to 4 places, it would be 0.0001. So you might have instances where on your homework, your p-value might be 0.0000, right? But it doesn't mean it's actually 0. It just means that it's very close to 0. So very tiny p-value. We're very convinced that there is indeed a difference here, that the men do stay longer than women. So we make our conclusion here. So since the p-value is equal to 0.0000875, which is less than 0.01, which is our alpha, we reject the null hypothesis. There is sufficient evidence to believe that men have, on average, longer of these short hospital stays than women. And so that concludes our hypothesis test.